So hey guys, welcome back to another lecture. So in our previous lecture we have seen the discrete random variables and continuous random variables. So today we're going to discuss the probability mass functions, probability density of functions. So what are these? So the probability of mass function is a function that describes the probability distribution of a discrete random variables. We have seen the discrete random variables, right? So this is a probability distribution of a discrete random variables. It assigns a probability to each value that the discrete random variable can take. I hope you understand. It means like it assigning some probability to each value that discrete random can take. Okay, so the function is defined only for discrete values of the random variable. It cannot be described for the continuous way. We have in continuous random variables. In continuous random variables, we have a probability density function. Okay, so the probability is assigned by the PMF. So what do you mean by PMF? The probability mass function are non-negative. So the probabilities cannot be non-negative, right? So these cannot be non-negative. So the sum of all possible probabilities of a PMF is equal. As I discussed now, the sum of all the sum of all probabilities is equal to the, just preview that lecture so that it will be easy for you. It kind of a recapitulate kind of stuff. So I hope you do that. Okay. So PMF can be used to calculate mean, variance, and other statistical properties of a discrete random variable and make predictions, inferences about the underlying system and a process based on observed data. So just a kind of a long information out there. So means like a PF can be used to calculate the mean. So what is mean? What is variance? We're going to cover in our next lecture. So don't worry. So it will be easy for you. Don't worry. Okay. So and other statistical properties. So what are those? We're going to cover in our next lecture. So as of now, just ignore that. Okay. So we have a function like we have a function like that. We have a probability mass function which is this is a big X, and we have a small x out there which is equal to the probability of x is equal to x. Means like we have a summation over here. So the probability mass function of x which is equal to 1 means like the sum of all probabilities sum is equal to 1. As I said na, the sum of all probabilities sum up is equal to 1. Okay, so the p of x is equal to 0 means like it cannot be negative. It cannot be negative, which means like it is 0 or 1 or between these two. It cannot be negative or it cannot be more than 1. I hope you understanding this. It cannot be negative or it cannot be more than 1. Definitely should be between 0 to 1. Either it may be 0 or either it may be 1 or between these two. Okay, so the PMF is a I just want to give a example so that we have a basic idea about what is going to be happen here. So the probability mass function of rolling a dice. So we just roll a dice here. So we just roll a dice here. And we get our what we get. We our desired outputs can be like this, right? So we have a six kind of outputs. It may be 1 2 3 4 5 6, right? So the first we have rolled a dice. It may be like a chance of 1 getting 1 is 1 by 6, and getting 2 is 1 by 6, and getting 3 is 1 by 6, and getting 4 which is also 1 by 6, and getting 5 and 6. The probability of that all are is equal to the 1 by 6, right? So the x is a discrete random variable which is 1 2 3 4 5 6, and we're gonna take that probability mass function over here. We just simply calculate that, and we will, if the probability mass function of the value of 6 means like the probability mass function of x if x is equal to 1, then it is 1 by 6, and the probability mass function of x is equal to 6, that is also is equal to the 1 by 6, right? So means like the probabilities can change along the input values change. It may be like a 1 by 6, right? So I just want to have a 2 twice, then it will become 2 by 6, that it will become 2 by 3. So it will change according to the input examples which we are given. Okay, so like the PF is a fundamental tool for analyzing the discrete data in many fields such as finance, artificial intelligence, machine learning, and data science. Means like, so the probability mass function is a fundamental tool for analyzing the discrete data. So it is the best function which is used for the analyzing the discrete data. So what do you mean by discrete data? means like which is countable, which is countable. Okay, so which is countable, so we are analyzing that data. So it is useful, it is a fundamental tool for analyzing that data, and it is also used in a many fields like a finance, machine learning, artificial intelligence, and data science, and a lot more. So I hope you understand this, what is probability mass function, and we're going to cover probability density function. So what do you mean by this probability density function? Means like it is also called as a PDFs. So the probability density function is a function that describes the probability distribution of a continuous random variable. So it just describes the probability distribution of a continuous random variables. It is giving the probability distribution of a discrete random variables, right? Discrete random variables, and it gives the probability distribution of a continuous random variables. Okay, so it assigns a probability density to each value to the continuous random variable can take, and rather than the probability, means like it assigning the probability density to each value that is continuous random variable can take, means like it assigning the each value each for each value in the continuous random variable rather than the probability. Okay, the function is defined for all values within a certain range, means like in a certain range 5, means like we have a code for in a python like for I in a range of 5 to 100, means like this is a range, this is a certain range, means 5 to 100. This is a function which is a continuous rather than like a discrete values which are used in a PMF like 1 2 3 4, right? This is just a set of a just a certain range, means like it can take values within a certain range, maybe like this 5 to 100. It can take any value. Okay, so the probability density is not negative. So as I said now, the probability of here also it is not negative, and here also it is not negative, means like probability cannot be negative, it cannot be negative. Okay, that is like the f of x, which is this function which cannot greater than or equal to 0 and less than or equal to 1 for all x, and the area under the curve which is PDF is equal to 1. We have discussed, right? We have discussed it. So we have discussed in our previous lecture. So what is area under the curve? It is integration, right? So it is integration. So we have integral f of x dfx which is equal to 1 or the range of a random variable. I hope you are understanding, right? So the PDF can be used to calculate the cumulative distribution function, mean, variance, and other statistical properties of the continuous variable. So we're going to cover each and every topic like cumulative distributive functions, mean, variance. So we're going to cover these mean, variance, and a lot more in the measures of central tendency. I hope so. In the measures of central tendency, we have a mean, median, and mode. So we have discussed a great detail over there. So I hope you love those lectures also. So like what is, so it is used to calculate the cumulative distribution function. So what is the cumulative distribution function? We're going to discuss just in a few minutes. Okay, so we're going to cover mean, variance, and other statistical properties of a continuous random variable. Okay, so the PDF can be used to make predictions and inferences about the underlying data and the process and the observed data as same as the PMF, which is a probability mass function, and the probability distribution function, which are used to make predictions and inferences about the underlying system and the process based on the observed data. Okay, so it is a fundamental tool for analyzing the continuous data. So it is meant for the continuous data, and that PMF is meant for the discrete data, right? So in a many fields such as a physics, engineering, finance, machine learning, and artificial intelligence, and etc. So it is graphically represented in a smooth curve like this. This is called as a smooth curve. I hope you've seen in our previous lecture. So if not, then just revisit those lectures, and you can have a basic intuition about this. So after that, we're going to cover the cumulative distributive function. So like what is cumulative distributive function? So it is a function that describes the probability of a random variable is less than or equal to as a certain value, means like it describes the probability that a random variable is less than or equal to certain value. I hope you understanding this. This random variables less than or equal to this certain describes the random variables that are less than or equal to the certain value. So it is a function of a random variable. It assigns the probability to each value or a range of values of a random variable. So it assigns each value, which is a discrete, and a range of all values at a random variable. And this is a continuous, right? The CDF is a non-decreasing function. That is, it increases monetically as a value of a random variable increases. Means like it cannot decrease. Means like it is not a decreasing function. It is always increase. If we have a more inputs, and then it always increase monetically as the value of a random variable increases. If we are having a more inputs, if we are having random variable increases, that means like we are having the more random variables, which is like having more inputs, then it is also increases, right? So the CDF of a discrete random variable is a step function, which the CDF is a continuous random variable is a smooth curve. Means like this means like in a discrete random variable, it is like a step. It is like a step, and in the continuous random variable, it is a kind of a smooth curve. It's a kind of a smooth curve. So means like it will give it will make sense in our further lectures. So as of now, just have a basic introduction about what is this CDF and what is this PDF and PMF. Okay, so the CDF of the cumulative distributive function of a random variable is a right continuous function, meaning that it is a value that changes only in a discrete points in a case of a random variables, and is continuous everywhere else in a case of a continuous variables. I hope you understand in that. So means like the CDF of a random variables is a right continuous function, meaning that it's a value changes only the discrete points in a case of a discrete variables. It is continuous everywhere else in a case of continuous variables. I hope you understand in that. So the CDF is a powerful tool for analyzing, visualizing the distribution of a random variable. So we can visualize those distributions. It is a powerful tool for visualizing the distributions of a random variable. It can be used to calculate the probability of an event. It can be also used to find the probability of an event, the probability range of values, and the other statistical properties of a random variable. So these are the use cases of the CDF, which is a cumulative distributive function. So I just want to recapitulate what I have said till for like, so what is this probability mass function, and what is this probability density function, and what is cumulative distributive function. So we have discussed these continuous random variables, right? So what is this probability mass function? It describes the probability distribution of the discrete random variables, and the probability distributive function, it describes the distribution of a continuous random variables. I hope you understand that. Okay, and it assigns the probability of each value for the discrete random variables can take, and in a PDF it assigns a probability distribution at each value that continuous random variable can take. So I am giving the differences between the I am giving the differences between the PDF and PMF, probability mass function and the probability distributive function. Sorry, probability density function. Okay, so the function is divided only in a discrete and at a random variable, and this function is defined only in a discrete, and the PDF which is only defined in a continuous. Okay, so the probability assigned is non-negative here, and those in a PDF also it is non-negative, means like it cannot be minus. It always like greater than or equal to 0 and less than or equal to 1. The value which is must be equal, is must be in this range. Okay, and the sum of all probabilities of a PMF is equal to 1, and the same it goes to the PDF. I hope you understand this. So we have given an example of a rolling a dice, like how we gonna find that the probability mass function out there, and this in this PDF which is a probability density function. I hope you understand these, what are the differences between the probability mass function and the probability density function. So after that we have a cumulative distributive function, right? So like as of now, like if you understand then it's okay. If you don't, then just ignore that as of now and revisit when we complete all these terminologies and a basic stuff in the probability, so that it will make sense, it will make it will make a better understanding like what is a cumulative distributive function. So I just recommend to go to Google and research about that. You will find a good examples out there, so that it will be easy for you to understand. Okay, so what do you mean by this cumulative distribution function? As I said na, it's just a function that describes the random variables is less than or equal to the certain value. So I hope you understand these CDF and PDF and this PMF. Okay, so I hope you understand this. In our next lecture we're going to cover the histograms, which are the main topic in the machine learning, and we have a density plots over there. So these are the main topics. Like we in our visualization and data analysis, these play the most critical role in the visualization. We have a distribution over here, normal distribution, and we this is a bell curve. So I'm going to explain in a great detail way, and we have expected values over there, and we have a lot of explanation over there, which is with the notes which is made by me, and the measures of central tendency. As I said now, we have a mean, median, and mode. So what is mean, what is median, what is mode? Okay, we have a great detail over there. We have a beautiful explanation with dells, and we have a quantiles, which is a we have a quantiles over there. What do you mean by this quantiles, percentiles, and after that we have a deciles. Okay, we have a lots of nodes over there. So we have a variance also. I just want you to research about I just want you to have a basic understanding like about the what is probability mass function and what is probability cumulative distributive function and probability density function. I hope you understand it pretty well. So if not, also don't worry, we're going to cover it again in our further lectures. So I hope you love this lecture, I hope you like this lecture. So if you don't understand, then please Google it. You will find a lot of examples out there. I hope you enjoyed this lecture. So until then, bye bye. See you in the next lecture.